Yeah, so hello everyone. This is Asif here. I'm the host for this webinar today. And today we are going to cover I3C protocol basics and conformance test suite, right? And we are seeing a lot of participation here. We see people from China, we are seeing people from Europe, and a lot of people from India. So based on the region which you are, so good morning for people in Europe and good afternoon for folks in China, and good afternoon for folks in India. This is going to be a pretty interesting session here. And the session is recorded. So in case you're going to have some internet connection issues and so on, don't be concerned. What we're going to do is we're going to record the session and send it to you. Overall, the session is for 1 hour duration. First 40 to 45 minutes is the technical presentation. And the last 15 minutes, we are going to open it for Q&A. So people who have questions, what you can do is go to the Q&A tab and type in your questions, and we'll be happy to answer those questions. Right. So let me quickly run through the introduction. So basically what we have seen is a lot of demand for I3C protocol, right? Almost all the semiconductor companies across the world are using I3C as a replacement for SPI and I2C, and we are seeing because of the speed and performance issues, right? And one of the most commonly asked questions is, we've integrated I3C into our SoC or in our device, right? But how do we ensure that it is conforming? Is there some conformance test suite which is available and so on, right? So recently MIPI had introduced, and Prodigy is the first one to come up with the test suite available for all the customers and so on. And that is where this whole session becomes very interesting. So to present this session, let me quickly give the introduction about the speakers. We have our technical panel. So we have Brijesh, who is a senior technical lead, and he has a very deep understanding of the MIPI I3C, has worked on UFS, RFFE, and SPI protocol specifications as well. And he's one of the contributing member. As you know, Prodigy is a contributing member to the I3C spec, right? And Brijesh is from our team, has been leading that, right? So overall, he has expertise in architecture definition, debugging, and he's one of the person in Prodigy who's written a lot of RTL and responsible for product development as well. So along with him, we have Manjunath. So Manjunath is the software engineer who's worked on the I3C protocol analyzer exercise. He has around 5 years of experience, and he also understands deeply the I3C spec and how the CTS or the conformal test suite works, right? So overall, I'm right now handing over to Brijesh and Manjunath. So they are going to take over and start presenting, and I'm going to be on mute. So I'm going to be back around 40-45 minutes from now, where I'll take on the questions. So keep the questions ready. So over to you, Brijesh. So the session is yours now.
Thank you, Asif. Godfrey, you want to add something here? Means introduction and all.
Sure. Let me do some initial introduction. Okay. I think I'm in a remote place. So thank you, Asif, and everyone. Okay. I think my name is Godfrey. I'm founder of Prodigy Technovations and also CEO. So basically, let me just give you a quick idea. Some of you may know about Prodigy. And can you go to the next slide, Brijesh? Yeah. So today's agenda, like we will be talking about a couple of slides about Prodigy, those who don't know about Prodigy, who are Prodigy, and we have been very actively talking about I3C and different protocol standards. So just to give you an idea what we have been doing. And Brijesh and Manjunath will take you through the I3C interface and conformance test suite, and what are the different test cases, and followed by a demo. And I think the question answer session will be very interesting. We have a very good experience working with the different customers. We have been working on I3C since year 2017. So the first I3C Plug Fest or interoperability event took place in Atlanta in US in 2017. And we have been participating every event after that. And we have been very closely and very deeply working with the different semicon companies. And it's a good opportunity for all of you to get your questions in front of Brijesh and Manjunath, so that we should be able to answer. And if there is something more questions, we will always come back to you because lack of time. Next slide, please. So about Prodigy, like we are headquartered in Bangalore, but we have distributors all over the world. We have distributors in Japan, Korea, Taiwan, China, Germany, France, Israel, and Italy. US, we are directly working on. And if you want to know more details about these distributors, please visit our website, prodigytechno.com, and in the contact tab, you will find our distributor's name. You can directly approach them, or you can always write to them, and we'll get back to you through our distributors. And we always involve our distributors so that you get a local support. So Prodigy started in year 2009, and we started with developing the software applications for Tektronix oscilloscope. And these applications are mainly doing some electrical measurements and protocol decode. But during this journey of the first couple of years, customers were expecting more powerful decoding capabilities, and they were limited by the scope's hardware capability. So we decided to develop our own protocol analyzers hardware, which is mainly based on FPGA. So in year 2014, we started with the eMMC protocol analyzer, which goes up to HS400 speed. And we launched that product in 2015. So we had a very good acceptance for this product in the market. And then we developed a range of protocol analyzers based on our own hardware, UFS 3.1. And those who have the requirement for UFS 4.0, they can always contact us. 100 base T1, I3C, RFFE, SPMI. And we continue to develop applications for oscilloscopes like Tektronix oscilloscope, whether it is a DPO older generation or a new generation from Tektronix like MSO 5 and 6. We continue to support Tektronix. So we have been recommended by Tektronix for many of your protocol decode solution. And you can always visit our website to know the latest information at prodigytechno.com. So that's about it. I think next slide. I think, yeah, I will be requesting Brijesh to take over from here, and Manjunath. So I'll be in the mute. If there's any questions for me, I will come online later on.
Thank you, Godfrey. So first, let's talk about I2C and SPI. So what were the drawback of that, and why MIPI come up with I3C, and what are the advantages of that? So actually in I2C, there was in that also clock and data line is there, but for interrupt there is additional line is required. So if you see at the system level, you need to have multiple IOs, and that will become a little bit complicated. And similarly in SPI also, there is a clock, data in, data out, and chip select for all individual slaves. So that is also making SPI as a complex architecture. And in that, it is not properly defined standard, because based on the application or it will have a different standard followed by the different companies. So that is why maybe come up with one I3C. So it has higher data bandwidth up to 33 Mbps in single lane. It has in-band interrupts, so that additional lines are not required. So less number of IOs, from one clock and one data line you can operate it. And it has flexibility to run from 1 kbps to 33 mbps. There are different modes are present in that standard, so that we'll discuss in the later slides. So this is how it looks like, means in that one controller will control multiple slaves with two IOs itself, clock and data line. So this is intended to improve the existing I2C and SPI interface So it has standard multi-drop interface between host processor, controller, or the sensor. So it is energy efficient. It requires less physical pins, and in SDR mode, it can go up to 12.5 Mbps. And I3C has legacy I2C device support also. So on the same network, it can have I3C device and I2C device on the network, and it can communicate with the I2C device. So here dynamic address assignment is there. So whenever new device I3C device sits on the bus, so controller will assign dynamic address to the target, and then onwards it will communicate with I3C commands. Before dynamic address, that I3C target will act as I2C target. So it has a high data rate. In high data rate, there are now it is 4 modes. One is DDR, TSL, TSP, and burst mode is introduced in the latest spec. So multi-master support is there. In-band interrupt means slave can initiate the interrupt when it want to send communicate with the host or the controller. And hot join support. This is like whenever, because in one system that's target is present on the bus, but it is in the power saving mode. So when it comes back, it can generate hot join request, and controller can assign the dynamic address to that I3C target, and it can start communicating with that. So let's talk about I3C specification status. Actually, first I3C 1.0 released in some later 16, actually 2017. And after that, they come up with basic specification, which is accessible to all the people. Only this I3C spec is only accessible by the MIPI members, but this basic spec can be accessible by anyone. So in 1.1 they have released in 2009, and 1.1.1 for main spec and basic spec they have released in 2021, and in CTS version 1.0 released in last August 2021 for MIPI members. But I think this month, or by this month end, they will make it public for this CTS version 1.0 to the public, so anyone can access that. So major feature is in 1.1 they have come up with multi-lane support. So because with one lane it can support up to 33 Mbps, but with multi-lane it has one lane, dual, and quad lane support. So it is to replace the SPI bandwidth actually. After that, it has HDR bulk transport mode and some other commands. So in I3C's basic specification, actually, as I mentioned previously, it was released in 2018, and 1.1.1 is released this year itself. So in 1.1, they have given feature. Previously, this timing control mode was not available in 1.0 basic spec, but this time 1.1.1, this timing control is available. Means only async mode 0 is available in basic spec. Other sync mode, async 1, async 2, and async 3 is still it is not available for that. And previously that DDR was not available in basic spec, but in 1.1 they have given provision for that also. So in 1.1 and basic spec, it has directed write, broadcast command, DDR, BT, set, ASA. So that features are common except this timing control and ternary, TSL and TSP. And for more information, you can contact MIPI Alliance. And so I3C data speed and data mode. So it support, as I mentioned, it support I2C device. So most legacy device can sit on the I3C network, because this is big revolution, right? Because most of the chips vendors are working on I2C, so they have to give backward compatibility. So this I3C will support both the one. So it has two mode. One is SDR and one is HDR, high data rate. So in SDR, there is three types of messages are there. One is broadcast, one is directed, and private read-write message. Broadcast means it will go, controller will send this message, and whatever targets are sitting on the bus, all will receive that command, and that field will be updated. For directed, it will talk one to one, and same private is used for private data transfer. So in HDR rate, there is HDR DDR. So in this, it will send data at both the edges. And TSL is for ternary legacy mode. If any I2C device is present on the bus, then master will, a controller will initiate TSL. And if all the I3C devices are present on the bus, then master can initiate TSP for ternary pure bus mode, and bulk transfer is to get the higher throughput. So I3C protocol supports means bus configuration, bus condition, dynamic address assignment, hot join mechanism, priority level, because controller can decide if, let's say, three sensors are sitting on the bus. So controller can decide which sensor has the highest priority. So it will assign the lowest dynamic address to that sensor. So whenever interrupt comes, it has a higher priority, and all the arbitration will happen in the first open range condition, where controller will send 7E command, 7E. So that time, if slave has any interrupt, it can initiate, it will have higher priority. But after repeated start condition, arbitration won't happen. It will move to push pull mode. So it will support HDR exit, HDR restart, and other command. So first thing in the I3C is to initiate the initialization process. So where controller will assign dynamic address to slave with these three different method. It's depend on the slave implementation, which method it is supporting. So enter DA, set DASA, and set ASA. Set ASA is like whenever, means whichever static address is there assigned for that I3C target. So same static address will become dynamic address. So that is the fastest method to assign dynamic address. And after that, if controller wants to change the priority level, then it can issue the set new DA command, and it can give new dynamic address to that slave. So this is packet format for enter DA. First it will send 7E, then command 7, repeated start, 7E read, and then slave will send its PID, BCR, DCR value. And in dynamic address phase, master will assign dynamic address. After that, if slave gives acknowledgement, it means the target has uh, got the dynamic address. So there are different directed commands are there. Actually, in I3C, they have given like maximum read length and write length. So if controller is sending some, let's say maximum write length is set in that slave for 10 bytes, and controller is sending more bytes, then after 10 bytes, it will ignore that data. And while reading, master as well as slave has the abort condition, means when slave is sending that data, in the T bit, it will give 0. It means slave is aborting this read operation. And if slave has given 1 in the T bit, and master wants to abort that conditions, then it will pull it low. So this feature is very helpful. If slave internal buffer is overflowing or something, then it will stop that operation. This feature was not available in I2C or SPI. So according to me, this is a good feature to have. And then it has bus characteristic register, PID, and device status. So from the controller can access this register through this directed command, and it can write and read back these registers. So now let's talk about our main topic of CTS. So this is conformance test suite for I3C main spec and I3C's basic spec. So conformance CTS is developed to improve the interoperability of product using I3C spec, because one vendor has developed a controller and other vendor has developed different sensors. So this is just good to have this test suite where it can send some transaction and it can check whether that target that sensor is behaving properly or not. So this test suite is providing a reasonable level of confidence for the DUT which we are testing, that most of the feature it will work, but it is maybe has not approved or clarified that any products are following the I3C spec via this official qualification program. Because maybe in USB they are giving certificate that this is certified. So that kind of certification things MIPI is not giving. This is to just check whether functionally it is working or not. So current CTS has only SDR device test, but and error recovery or error detection methods are included in the test suite. But the DDR is still under consideration. So for this CTS 1.0, only SDR mode is getting tested. But in that case also enter HDR mode and HDR tolerance, HDR restart and exit is still in the scope, but DDR is under consideration. So this is actually living document in the I3C working group, and in future revision it will have this optional features also. So let's talk about our I3C EXPD support. Means our device can means what are the tests our device can perform under CTS conformance test suite. So this is it has multiple sections. One is controller test and one is target test. So in controller test, there is first group. It will check for the I3C bus operation. So it has only start, repeated start, stop condition after egg-neck behavior, and how controller will able to handle IBI request, because IBI will be generated from the target. So it will pull that SDA line low, and the master has to acknowledge, and it has to send the clock for the slave. So then slave will send its dynamic address and it will finish it interrupts actually. So after that, how HDR exit pattern can be generated, HDR restart. So all the test cases are defined in the MIPI CTS, because currently it is not available for public. So we cannot go into deep explanation. So I'll just give you the brief thing that these are the test cases are there, and uh, uh, we are supporting or not. So in that group 2, it is CCC test. So it has, as I mentioned, it has broadcast and directed command. So broadcast has, in the CTS, they have covered ENAC, DSEC, reset DA, enter DA, set ASA command, set DASA, set new DA, get PID. So controller will send this command, and they will check for the response from the target. So whether it has given proper response, whether it has sent properly or not, that information we can see in the GUI. So after that, they have group 3, where it is having error detection and recovery method. So CE0 is illegal formatted CCC. Okay, so whenever, let's say they have sent get PID command, so get PID command has 6 byte, means controller will expect 6 byte to return from the slave. But if slave is aborting after 1 byte or 2 byte, then controller will initiate same command again, and it will retry, and it will, that depends on the controller implementation how many times it will retry. But uh, if it is retrying for next time and the slave is giving 6 byte of PID properly, then it means it recovered from this error. After that, CE2, there whenever because in I3C, every time it will send 7E command, that is broadcast address. Okay, 7E broadcast address. So for that 7E broadcast address, all the slaves should give acknowledgement. If they are not getting acknowledgement, means in the target it can be like T0, T1 or T2, some errors are there. So it will initiate the HDR exit pattern followed by the stop. So that is error recovery method from the slave side, T1 or T2. So it will initiate that HDR exit automatically, and then it will send 7E right again, and it will check for the response. So currently CE3 we are not supporting in our product, because this is for handshake between multi-master, secondary master. This we will support in the future. Actually, this is there in our roadmap. And after that we have slave means target test case, where there are different groups. First is for operational test, where it will check for the start, repeated start, same as master side. But here it has multiple sub test also, where it will check whether uh, uh, all the commands are as per the I3C standard or not, or whether the slave is coming out from the recovery or not. So that are the test cases are mentioned in that. After that, DDR target CCC test, it has broadcast directed and retry model response. So it will this test you can generate from our controller, because in this target case means means DUT is target actually. So all these tests you can generate through our controller. And T0 is like if instead of 7E, controller has means target has detected 3E, 5E, 6E, and some other value which is defined in the spec, then it will go into TE. Then master has to send the recovery method, and it will come out. So T1 is T1 is CCC parity error. So after that, controller has to send HDR exit. TE2 is for write data parity, because whenever write operation happens, after every byte it is sending T. In that T, it is parity bit, and in that if error occurs, then appropriately it will send the recovery method. And TE4 is when enter dynamic address assignment is command is sent, and the master is assigning dynamic address with wrong parity, then this error will occur in the target side. So it will wait for the stop, and it will again wait for enter DA command. And T5 is illegal formatted CCC. If let's say get PID command is sent from the controller, but actually it is read command. So if controller has given a write bit set for the dynamic address, then it is a T5 error on the target side, and uh, uh, to recover from that, it will wait for the next command, or it will wait for the proper read read address and read. Then it will give its PID value. So that is also supported, and it has a reset ACT pattern. Actually, if this pattern is sent and whatever defined action is there currently in this CTS, it will not reset the any peripheral or device. So it is set to 00, but it has some test case where it will send this target reset pattern. Okay, so now this is our CTS user interface. So where, as you can see here, we have selected the mode as CTS, and device under test is slave. So it is like external slave is we need to test. So all the test case we need to generate from our controller or master. So you can select multiple test case. In this UI we have shown, we have selected 11 test case, and once you press send, it will show the status how many test case has been run, and if it means green means it is passed, it is as per the CTS, and it is as per the spec means slave has given proper response to this commands. And next is fail scenario. Whenever it is failing, we are mark it as cross. And here we are giving comment like invalid data. We are expecting some data 55, but we receive 56. So it means this is failed scenario. So in total 11 test case, 8 got passed and 3 got failed. And uh, we'll put it in the report that these test cases are pass or fail. And now let's move on to live demo. I'll request Manjunath to take control, and please give the demo.
Thank you, Brijesh. Hello, everyone. Share your screen. This is how the I3C XPD UI look like, or this is the initial UI. So I have connected my I3C Prodigy EXPD into my internally looped back. So I will be checking the connection here. So once it says connection established successfully, so that means the hardware and the software has communicated properly. So we can go further actions. So here we will have let me quickly go through windows here. The first window is setup window. This is for trigger, this is for EXPD I'm explaining. So this is to trigger on particular message and particular frame. Then you want to trigger in advanced trigger particular level, then we will use this window. This is plot window where we'll get all the detailed information about each frame, beginning from start to stop. So here you will have the exerciser detailed configuration, like what master configuration and slave configuration. Everything will be here in this window. And here at the right side, we will have a decoded result and the selected frame view. So where we'll get all the frame decoded results and the packet, whichever along with the timestamp and the data and frequency, everything will be here. So this is brief about the windows here. After that, so we have a two mode. One is by default EXPD. It is a CT, right? I mean, in the latest software, we have added a CTS. So additionally, so let me choose CTS. So once you use CTS, so by default it will take the input from the user. Slave, what type of slave you want to test. Let me write it as Prodigy slave I am testing. So version, if you want to put anything like 1.0, and any serial number, duty, description, engineer name. So all these will be taken as a input from the user. So after that, we will put it as submit. So once it says submit, the window will be like what to add configuration. So I will add a master, internal master. So here I will let me brief tell about this information. Node type is user can configure either master, slave, or I2C slave or secondary master. Interface means whether it is our device or it is any external device we need to test or add. Termination means it is on or off. So it is a pull-up register. If it is available in your slave device, you can turn it off. If it is not there, you can turn it on. And voltage, we can vary it from 1.2 3.3 voltage instead of 100 millivolts. So we also have trigger out and trigger in option, which is just to see trigger. By default it is trigger out. It is just to check the trigger pulse. Whenever you trigger, we can see the 100 nanosecond pulse on the oscilloscope. So when it is trigger in that case, it act like as a IBI. So slave can initiate interrupts transactions. So let me add an internal master here, and I'm also testing I3C slave. So it is mentioned DUT to be test is slave. So I'm testing internal slave. So whenever you want to test your device, you can put it as external and uh, write down your PID and address unknown. So 45 is my static address, and the voltage I am supporting 3.3. So I will also configure BCR, DCR, PID registers. So BCR, our device will support HDR capable. So I put it as HDR capable. So this DCR configuration, it is, your sensor register, we will put it as memory. So these are PID, it is useful here. MIPI manufacturer ID is required to mainly just to assign dynamic addressment. So I just give it as part ID1. We are one of MIPI members, so it came here, Prodigy Technovations under the list. So then I will close it and I'll add it. So then in a bus network, I can see whatever I added. Main master, I have added all the list I can see, and the I3C slave, I can see all the information whichever I added. So then I will say it is done. So then I can see the list of all the slave test cases here. So let me go group wise, group 1, group 2, group 3, group 4, as per whatever I3C CTS standard. So all the test cases has been listed down here. So it is like target error detection, reset tests, and target all CCCs, and I3C bus operation, all the test cases. Let me start with a single test cases. I3C bus condition timing. This condition, it is actually to test the inter-message gap between the two frames. So let me start my capture and acquire it. So it says it's processing. So once it get done, we'll see an option. It is whether it is pass or fail indication here. It is pass. So this is how it is. As per test CTS standard, it has to. Like this test case is to measure the timing. So the timing gap between the two frames should be as per CTS standard. So it is there. So it is says pass. So we can also have a control here. We can link to that particular test cases. So we will also have a test ID, which is corresponding to particular test case. So then I will run some few more test cases like exit and exit DIA, then ACNAC, and Yeah. So every time when you click on it, it will reprocess from the beginning. So first test case which I selected is been completed. So when I click it, it will say, oh, these many things. So in this I3C bus stop target is actually exit from the directed GCC. It give after dynamic address, it will give abort condition, stop condition. So in the second one, it will exit after DA. I mean, once the dynamic addressment has been assigned, after again that user want again if you want to assign as a dynamic address, then it will abort. It will give an ACK. In that case, it is exit from the DA, dynamic address process. So this is about second test case. Then third one is when I click again, it will point to that, and waveform also it will get updated as per new test cases. It is 215. So every time it is we are assigning dynamic address to each test cases, then followed by as per CTS standard test cases. So it is like 7E ACK, and it is giving ACK to the dynamic address. ACK is our dynamic address is 8 actually. You can see it in slave. So it is assigned as 8. So it is giving ACK to the address. So it will give NAC. So it is ACK and NAC feature. So it will give NAC when uh, it is for unreserved address or any other than dynamic address. For 6F, it is giving NAC. This is one kind of test cases as per CTS. So to check the ACK and NAC capability. So then we'll have I3C here, parity checking also is there, S1 error and S5 error. So it is all these fail condition. So whenever it is 7E right and NAC, then it will come out, this HDR exit is to come out of that error. So error recovery will be given by HDR exit. So yeah, this is all about past condition. Some few I will explain. We can select all also and run it. At the end we can generate report also. So some of the test cases I will select which no dynamic address and no static address. So it is if the test if the slave has not assigned any dynamic address and no static address is there, then what will your slave respond? That test cases you want to test. So it will give an ACK to every addresses like from 0 to everything. So it will giving ACK. So it is pass condition. So there are few more, many are there as like that. So I will let me go to one more test cases where it get failed. So ENT HDR test here actually it is to till HTR3 our slave has given ACK actually, an ACK actually. For few it is given NAC, so we have not implemented those features. I mean HDR4 and 5, 6, 7. So for that we are giving ACK. So wherever it get failed, we will mark it as red like this. So this is all about thing. We have, I mean, we can do it for all the test cases, group 1, group 3. And at the end, we'll see CTS demo. Once you run it, we'll see all the, how many get passed and how many get failed. This information will be here. And at the end, you will see if you want to run this and generate a report at the end of all the test cases, we can do that also. So this is with GUI, you can able to do it. And also we can do the same thing with your API. We can do it in Python and C++. And you don't need to use a GUI application to do it this test casing. So where you can use it in your Python or your any project, new project, and there you can import our DLL and just you can assign the particular checkbox where whichever test case you want to select and select it and run it. At the end, we'll have a report which pass, which are failed, and also with the images which are failed, pass and failed. So we'll have this plot window image whether it is pass or fail. Let me quickly go to report here. I just generate this one. It is generated. Is it? Yeah, this is how the report look like. It is PZY conformance test shoot report. These are the things which are taken as an input from the user at the beginning. So I have name it like Prodigy slave and version, all the things. In the second page, we'll have configuration, what master has configured and what slave has configuration, like PID, BCR, DCR information will be here. Followed that, we'll have a CTS summary results, like how many test cases you have selected and how many got passed. So I selected 3 and at the end I got passed all 3. So also I will have a test case ID with the test case description. So each test case ID like 211, 214, these are the MIPI described test codes. So these test codes accordingly I can see corresponding whether it is pass or fail indication. Then we'll have a protocol list. This is optional thing where they can check it or uncheck it. If it is they checked it, then we can see it in the report. Like each test case, what protocol frame has came here. Like ours ran 211, so it is like broadcast 70 right everywhere. So it is just to check the timing control. Then in the second 2141, it is HDR exit thing, exit from DIA and exit from. So whatever, I mean, test cases we are in, at the end we can able to generate those report. I have not attached a report image here. You can attach the report images also along with that. Yeah, I think that's it from my end.
Yeah. Hello, everyone. Yeah, I think thanks, Brijesh and Manjunath, for the excellent presentation and the demo. So we'll be taking up the Q&A right now. So I already have the first question here. Can we get the list of test cases at the end of the meeting?
Thank you, Manjunath, for the brief demo. So now let's talk about some other
You have something.
products which is available from the Prodigy, and we have I3C EXPD, which is exerciser and protocol analyzer. From that you can generate the traffic and you can see in the analyzer, but it will not do electrical validation. So for that we have measurement and analysis software which will do electrical validation for I3C, I2C. Okay, so this all the scope software works with the Tektronix oscilloscope and Windows-based oscilloscope. You can install this software and you can tap I2C, I3C lines, and you can get the rise time, fall time information from this software. So,
okay, Brijesh, any other slides, or you're pretty much done? So I'll open up for Q&A, right? Hello.
Yeah, that's pretty much, I think, Asif, you can go ahead.
Yeah. So first question here is, can we get the list of test cases at the end of the meeting?
Yeah, actually it is covered here. We have covered all the test cases in this PPT itself. So these are all the test cases.
Okay. There's a couple of more questions here. Can the I3C exerciser be used for timing characterizations? Can we set rise time and fall time?
I3C exerciser, no. We from our exerciser, that functionality is not there. We cannot generate. We cannot vary that rise time and fall time, but we can vary duty cycle, high time, low time. We can vary. We can change the frequency. we can change clock to queue delay in a step of 18 picosecond. After that, we can vary TCAS. We can change stop setup time, repeated start setup time, and we are supporting from 1 kilohertz to 12.5 megahertz frequency variation. So uh, other functionalities are there, but rise time fall time feature is currently it is not available. In future, maybe we'll support that.
Okay. So what Tektronix oscilloscope model does the software work on?
It will just analyze the characteristic. Or Godfrey, you want to take this question?
No, which model? Oscilloscope model?
Yeah. Let me answer this question. It will support MSO 5 and 6 series. Okay. And also Tektronix previous Windows oscilloscope like DPO 5000, DPO 7000, DPO MSO 70,000, all those oscilloscope it supported. It's not supported on the DPO 4K or 3K series. Yeah.
Okay. Is automation possible? Is it possible to execute a command line feature?
Yes, automation is possible. You can use API in Python or C++ and use the DLL to do the automation.
Okay. I think a lot of questions are coming in. So basically, the session is recorded completely and it's even live streamed. So at the end of the, maybe by tomorrow, what we are going to do is we are going to share the YouTube link where you can kind of see the sessions as such, right? So some of you guys were asking for PPT. So you can go in our YouTube channel, subscribe to our YouTube channel and watch the recorded session anyways. Yeah. So there's another question here. To exercise the test suite, is it necessary to have a particular software, that is DUT, answer loop or other?
Question is not very clear. Maybe he
Okay.
can write an email to us and we will respond to him. He can write an email to contact@prodigytechno.com.
Okay. And I don't know, Saifuddin is asking one question. What micro do you use?
Yeah, even Safiuddin also can approach us through the email. Yeah.
Email. So what you can do is, if you have very specific question with respect to product, Brijesh, you can show the slide deck where you have the contact. Yeah. So what you can do is you can write an email to contact@prodigytechno.com. We'll be happy to answer your questions. And if people are interested in one-on-one demos as well, those demos also can be scheduled, right? So some of them like Abhishek and some of the guys are asking price of the hardware and all. So what I would request is, please drop in an email immediately after the session, contact@prodigytechno.com. Our, the application team or the sales team will get in touch with you with respect to the cost and the pricing models and so on. Any other questions? I'm happy to take. Yeah, okay. There's one interesting question here. Can we use Prodigy API library in Linux?
That's a very good question. Yeah, I think we are working on that actually. Mr. Kasia, right? Yeah, you can please write to us if you have our unit and we can reply.
Okay.
Yeah.
Let me see. There's some more questions coming. I know, guys. This is quite an interesting session. A lot of people are excited and want to ask a lot of questions. So let me see if I missed out any other questions. Okay, there's one question here which I missed. Suppose I have a microcontroller and an IMU sensor. Can you suggest how to use I3C protocol for communication between the microcontroller and sensors?
Okay, again, this is a very detailed technical question. Okay, whether you want to validate the microcontroller or the sensor, we don't know. But if you just want to monitor the traffic, you can use this product. We also have one more product which helps you to just monitor the I3C traffic between the master and slave. Like this session is for conformance test suite, right? We are talking about only how to do that. But if you just want to monitor the traffic, you can use Prodigy Discovery Series logic analyzer, which supports I3C protocol analysis apart from other interfaces like I2C, SPI, UART, RFFE, and SPMI. And maybe in future, some more would be coming in that line. Yeah.
Okay. Okay. Yes. Okay. Is API library in Linux available for customers? I think that's the same.
Yeah, please contact us.
Yeah. So I think in the interest of time, because we are also running out of time and I have only 4 minutes left. So what I'm going to do is I'm going to wrap up this session unless I find some very interesting question. So what I have done is, we have put in the display here our contact address. So please feel free to connect, contact@prodigytechno.com. This is a recorded session. The session will be sent, recorded YouTube video link will be sent to you. You can listen to the sessions. And people who are interested, right? I mean, who want to have, use the CTS test suite, or who are interested in I3C protocol analyzer or exercises, please feel free to set up a one-on-one demo session or one-on-one sessions with us. We'll be happy to support that. And thank you, Godfrey. Thank you, Brijesh, and thanks, Manjunath, and thanks everyone for joining the session. I know this was quite an interesting to know about I3C protocol and CTS, right? So we'll be coming up with the next series of webinar, and we'll be happy to share with you, further details. Thanks everyone for joining. And with this, I'm going to wrap up the session. Thanks. Bye.